In this video, we're going to be covering another SQL question. This is question number 178 on Leetcode. This is called a rank scores. So we have been given IDs and scores in here. They are not sorted. The scores are, if you look at the schema here, are going to be the decimal. Whenever you see a decimal type with two digits in it or two arguments in it, the first one actually tells you the total numbers allowed before the decimal point, and the second argument is gonna dictate how many digits are allowed after the decimal point. So we are filling in these values, right? They are multiple ones, multiple scores. What they are asking us to do is to rank the scores, and that would be that the top scorer is 4 point. You can consider it as a GPA too. So the top GPA is 4.00 with the rank 1. Here's another one who got 4.00 with a rank 1. Both of them are ranked 1. Then we have a person with a score 3.85. That's going to be ranked 2. And then we have 3.65, 3.65. Both of them are going to be ranked 3. And then 3.50 is going to be ranked 4. Nice. So there is the first approach is to do through this function, which is the dense underscore rank. This is a function which is a window function, and I will explain what that is in a bit, but this is made for it. Dense rank is gonna go through and look at the score, put them in the descending order, right? Descending order meaning the score is gonna be this. So descending order, putting them in the descending order is gonna give us this sequence. But the rank is automatically dense rank over, and over is the one which makes it a window function, and it's gonna automatically not only gonna tell you which one is the order, like which one, it's not just incrementing it, it is automatically calculating the rank based on the density, and it does not increment the rank if the score is equal and all by its own. What window function is like, basically the definition of a window function would be that it does, or it produces aggregate like results for each query row. So let's say if you want to sum something, right? If you want to sum the scores, this is not an window function. Why? Because you will notice that if I put it in, if I do the sum of something in this score, it's just gonna create one result, one row. But if I do over this becomes a window function, that it's gonna say the sum of the scores, which is gonna be taking the sum of all these GPAs and then summing and then adding them together, and then it's gonna display it 1 2 3 4 5 6 times in 6 different rows. So this is called a window function, and it does that over a window function, and that's there is no more explanation to it. That is how it is created, that it would not, it would give the same rank to the similar or to the same scores, and would increment the rank for the next one. The next one is a correlated subquery. What it does is, like, basically you have this one over here on the left side, right? Think of it that I take this one as a set, and I bring in the first entry in here and compare that whole set with the first entry, right? So I'm looking at it, and I have another set, another, I don't know if you can see my mouse, but I have another imaginary set in front of it with this entry, right? So this is the sub query. I can actually take that. Once I have that, what I'm asking him is like the current score where I am is 3.50 and an imaginary set in front of you. Tell me how many times did you see this score greater or equal to the imaginary set? It would say 3.50. It would say actually four times. There are four different distinct instances where I saw that you were smaller, uh, where you were actually smaller than that one. So the rank given to that instant is gonna be, for the distinct ones, it's gonna be 4. So basically you are actually going through the score as an S1, as an individual S1 score, and then you are comparing that, basically that whole thing, with every single one more time, right? One more time, and then you are basically saying that, like that whole thing, you're gonna go through all of it and tell me how many times that score is greater than or equal to that current score. So it will say four times. It is, you will find instances of four of these when comparing to the first entry. So that what you're gonna be returning for that particular score. And we're gonna take the second entry, uh, apply the same algorithm with an imaginary set of all of it again, and tell, say that how many times this value is actually, like the whole of it, how many instances are there in the imaginary set which are greater than or equal to this entry. So you're gonna be, see there are three distinct instances. That would do the correlated sub query. Another way which is very similar, instead of actually doing it imaginarily, you can actually join them. So let's just do that. You can join the two. So we are saying that, oops, okay, we are taking our S and again the scores SST, both joining them, but the joining is very different. uh, Joining is, like you are actually looking into, you are only joining uh, when you see that the score is actually less than equal to the score of the other one, and at that instance you're gonna be taking into effect, and in the end you actually return that. I'm gonna display this one in a more elaborate form, into in the terminal. So I will start recording once I am on the terminal again. So now I am in terminal, and let's see what I wanted to show. Basically, let's see what we have inside our from the scores. Yes, we have this thing, right? We have these 6 entries, and if I just select everything from scores S and the inner join scores T on S dot score is less than equal to T dot score, and let's just say that we want to order it, order by S dot score in the descending order. So what I did is like I inner join, just the inner join, but on this condition that the S score is gonna be less than equal to the T score. So you will see that I'm gonna be going through, there are gonna be a total of 6 multiplied by 6 instances where I can join. And I can show you that if I do select from scores S, inner join scores T on 1 equals to 1, you will see that the total the ways I can join one table to itself is 36, because every single entry is going to be joining with the other 6 entries. That's going to make a total of 36. But I say no, just join them when you see the current the left side of the table score less than or equal to the t side of the other side of it. So we're going to end up having 23 different instances here. What it means is like I am here and the next one is either gonna be equal or greater than the left side of the value. So that's why we are seeing these ones in here. Then for the 85 I'm seeing this one or this one. So what I'm gonna do now is like basically think that now I know that if I take the distinct values, I can count the instances where I can count the instances where like how many distinct times the left hand side was actually equal or greater than the right hand side. So over here the value is gonna be 1 because there is only one distinct instance where this 4 was less than or equal to the right side of the 4. For 3.85 the answer is gonna be 2 because there are only two distinct instances where 3.85 is either equal to or less than the the 4. Then 3.65 we're gonna keep going until here, so there are three distinct instances where the left hand side is going to be less than equal to this one, and 3.50 you're going to have four distinct instances where this was less than equal to that. That's why when you do that you're going to end up having, okay, this one is 1, 4 is 1, 3.85 is second. So that's how you can calculate the ranks too. That's the third way of calculating, doing this, solving this problem. That's all I wanted to cover. Thanks for watching.